So I'm going to set 3x plus 5 equal to 17. I'll subtract 5, divide by 3. 3x plus 5 equals negative 17. Subtract 5. X equals negative 7 1/3. Or negative 7.33 or negative 22/3. Okay, they're all the same thing. Looking at number 2, the absolute value is by itself. So what do I need to do here? Set 3x minus 9 equal to what? Okay. Do I also need to set it to negative 0? Is negative 0 a thing? No. Okay. If you put negative 0, I won't mean to be rude, but I'll be the first one you hear laughing at you. Okay? So, make sure that you know you cannot have negative 0. Alright? So, most of these problems, well, let's go ahead and answer the next one first. Sorry. So, what's the first thing I need to do on 3? Okay? After that, Brooke, what do I need to do?
Then you make your equation. Oh, talking about that?
Yep.
You need to calculate it.
Nope.
Oh, no, wait, it's not. It's no solution.
No solution. Why is it no solution? Somebody tell me why it's no solution.
Because you can't have a negative. Yeah, it's a negative.
Because of that negative right there. Okay, now looking at these real quick before we go on to the notes. Alright, this problem right here, the very first problem. That's a pretty basic problem. Okay, we've looked at the graph, crosses it twice. It's good. On the other one, this is one where you had that and then you had that horizontal line. They don't cross at all, so there is no solution. What would the graph look like in this case? Where there's just one solution. Nope.
It would be like an X. So,
What do you mean an X?
wait, if there's one solution,
Yes.
then it would just be one number, one dot.
Draw
Oh,
it.
I'm
Draw
so
it in that area.
scared. What if I'm wrong? Okay. Would it look like this, and then like that's your solution?
Nope.
Okay, I tried and it's fine.
You still got an absolute value. So you still have this.
Oh, it would be like. Oh gosh.
Where would the horizontal line be?
Right below it.
Do what?
Right below the vertex.
Okay, not right below it, but it's going to
Touch the origin.
it's going to go right through the vertex. Okay, so kind of it's very rare that you'll see that, but just wanted to show it to you so you know that that's what that graph would look like.
That's for no solution.
No, that would be for the middle one, the one solution. The one to the right is no solution. Now, going to this problem, and kind of follow me here because we're going to do this a little bit different than what the notes say because I want to be consistent with how we're doing this. So, right here where it says 1, graph these two, we're not going to do that. So, if we were solving this, that problem right there, whether it's by graphing or if it's algebraically, what's the first thing I need to do?
Isolate the absolute value.
Okay, so I would do that by doing what, Dawson?
Subtracting 2.
Subtract 2. So I've got the absolute value of x minus 3 is greater than or equal to 2. So I'm going to take those and I will graph those. X minus 3, which direction is that going to move?
Right.
To the right, 3. There's the right side, there's the left side, and then I've got the line y equals 2. Okay, so you would have this point right here, that x value is 1, that x value is 5. That's all you have to identify on that. We'll get to the shading and it actually being an inequality here in just a second. So if we were to do it by solving, it's and this is why we're doing the graphing differently, because I want to be consistent. Okay, you would subtract 2, and then from there, if you were doing it algebraically, you would do what you did on the problems on the warm-up. Set it equal to positive 2. There's your intersection of 5. Set it equal to negative 2. There it is at 1. So next it says locate the solutions for, and we didn't graph that, we graphed this. On the graph and shade. Okay, so if you're doing it on a graph, now most of these we're going to end up doing on a number line, which I think whenever we do a few examples, it makes a little more sense. It's a little simple, it's a little easier, I think. But if you're doing it on X and Y on a grid, I want you to kind of see it as 3 different sections based on where those intersections are happening, so where those solutions are. Okay, and you're looking at that. Okay, those vertical sections on the graph. And you're trying to figure out when the absolute value is above the horizontal line. So if you can kind of read that as that, when is the absolute value greater than or equal to or above the horizontal line, that's what you're looking at. Within each section, you're looking to see if it's above or below, because it's greater than. So looking at the first section, is the absolute value, the part I have highlighted in blue, is that above or below the horizontal line? Above or below? Above. Thank you. Okay. So because that fits the inequality, that's the part that I'm going to shade. In this middle section, is the absolute value above or below the horizontal line? It's what? The absolute value? So this part, is this part above or below the horizontal line? Below. So I wouldn't shade these x values. In this section, is the absolute value, is that above or below the horizontal line? Above. So I would shade those. So next, let's look down at the number line, and let's talk about what it's going to look like down here. So if you're doing it algebraically, and this is probably the big idea for today, because the rest of these we'll be doing algebraically. Still going to do the very first thing of subtracting 2. That's not going to change. After that, you're still going to take x minus 3 and 2, and then in this another equation, you're going to do x minus 3 and negative 2. Now, it's not equal to. You've got inequality on this, and so this is where the big difference between today is compared to last class, whenever that was. The equation that you set up with the positive 2, you're going to keep the sign that's in the problem. With the one that has negative 2, you're going to flip the sign the other way. And then you'll go through solving that just like normal. So you'll add 3 on both of them. So I've got x is greater than or equal to 5. And I've got x is less than or equal to 1. Now let me show you how I put this on this number line. You don't always have to do this, but I want everybody to do it at least for now. I'm going to put a rough absolute value on the number line like that. My 2 solutions are 1 and 5. And so this is a number line, so the lower value goes on the left. The higher value goes on the right. Whenever you're shading, there's two different ways you can do it. If you just understand how inequalities work, awesome. It's pretty easy to tell, okay, x is greater than or equal to 5, so I'm going to shade where the numbers are greater. X is less than or equal to 1, so I'm going to shade where the numbers are lower. You can do it that way. What has helped a lot of people is if you take, for example, my solution of 5, if I take that inequality and I write it above that value, and kind of look up here as I'm drawing this. If I can see that inequality as an arrow, that arrow is going to tell me which side to shade on that point. If I put the inequality, and then the other one is less than or equal to, so if I use that inequality as an arrow, it's going to tell me which side to shade over there. If that helps you, awesome. Once you're done with that, go ahead and turn the page. We'll go through a few more examples of this, and then you'll have some that you can work with all your good buddies that you're sitting next to. Ava? Huh? Alright, so looking at the instructions up top. Sarah Clark. McKillips. Thank you. Okay. Up here it has the instructions to solving absolute value inequalities. Everything I'm highlighting up here is all the same as what we did last class. The only difference is whenever you have the one negative, one positive, and you're flipping the sign. So really just the flipping the sign. Okay? Make sure that the flip sign goes with the negative. The sign, the inequality that's in the problem goes with the positive one. Okay, so if I take number 5, and I've got x minus 3, and then positive 4, excuse me. Logan, what is that inequality going to be? Greater than or equal to, or less than or equal to? Greater than or equal to. Keenan, what is going to go with this one? The negative 4.
Negative 4, less than or equal to.
Okay. From there, I just solve, so I add 3. I add 3. Got negative 1 and 7. If it helps you to put the inequality signs above, then you can do that to do your shading. Sorry. 6. So, Chris, 4x plus 12. And then what's going to go with the positive 20? What inequality is going to go with that positive 20?
Greater than
What's in the original problem?
4x plus 12.
What inequality is in the original?
Oh, okay, I'm so dumb. I mean, I can solve it. I don't know, like.
What do you call this right here, Chris?
I know the sign.
What is it called?
Inequality.
It is an inequality, that's right, but what is its name?
Fraction.
Less,
Oh, no, that's not a fraction.
less than or equal to, or greater than or equal to? It's one of those.
I said that was greater than or equal to.
Dude, just
Okay.
stop asking me questions.
But it's not. It's less than or equal to.
No, 20 is greater than or equal to 4x plus 12.
Okay, so you're going to do that, and then you're also going to solve 4x plus 12 is greater than or equal to negative 20. So on both of these, you'll subtract 12, divide by 4.
Dude, that's the last thing
Wait, you can't divide by 4 first.
I don't know what he was looking for.
Zach got me a different answer.
Do not divide. SADMET backwards. Or sorry, PIMDOS backwards. It is SADMET.
Yeah.
Okay, so on this one, this is a little different than the two we've had so far. You've got negative 4 and your inequality is there. You've got 2. And it should not be negative 4, it should be negative 8. The inequality with positive 2 is less than or equal to. So if the arrows are both pointing in, then you're going to shade the area inside the points. Looking at number 7, Keenan, what's the first thing I need to do?
Set on inequalities, so you go. It's a fraction.
Okay, first thing you're going to do is divide by 3. So you got the absolute value of x plus 6 is greater than 18. Alright, and so, Nick, if I've got x plus 6 and positive 18, sorry, I need to divide 18 by 3, which should have given me 6 there. Okay, Nick, what inequality is going to go here? Greater than. So I get x is greater than 0. Peter, if I have x plus 6 and then negative 6, what's going to go in front of the negative 6? What inequality is going to go right there? What's the other one called? Less than. And then I subtract 6. Whenever I do this, look up here real quick. I don't know, because I wrote it wrong. Somebody tell me what's wrong with that. Yep.
Divide by.
Swing and a miss. Peter, what's the first thing I need to do on 8? Subtract 5.
I didn't see the 5.
Okay, going back to Chris. Chris, what do I need to do now?
Now you divide by 3. You're so close. I didn't see the plus 5.
Now, Cameron, what am I going to do with that? I'm going to take x plus 2, and I'm going to do what with it?
You say, it's going to be less than or equal to.
Okay, and what's going to go in the other one?
It's going to be greater than or equal to.
Greater than or equal to what?
Negative 6.
Okay. Then I'm going to subtract 2 on both of them. So I've got negative 8. And I've got 4. And it is telling me to shade inside those. So what you're going to do on the rest of the practice problems. I agree.
Is number one?
But I think it's like an industry.
Yeah, it's on the board. Oh, I'm sorry.
Negatives are
It is
plural.
hard.
Because I didn't look at it.
What's the plural of nemesis?
It's a Latin root, so it'd be I.
What?
That's obvious.
Someone else means no, it's not.
What's the plural of I?
Look at all those nooses. You understand that? Yeah, you're like,
You don't know how to solve this important.
I don't.
Good job.
I did not go to the swimming on Saturday.
He's giving it to me. He's working at
I did not know that you two were brothers until last class.
What? I did not know that. Someone was saying that we sound alike.
I just said that you do something.
Okay, whenever you do both signs, you get the same answer on both of them, but you'll get x is greater than or equal to -3, and x is less than or equal to -3. Okay, so you would go, obviously the only point you've got is -3. Okay, but then you've got both signs technically on it. And I mean, if you follow the rules, you're fine. You end up shading the whole thing. Okay, this is one of the ones that if we were to draw the absolute value, you're looking at something like that, and it's asking. Okay, and you go both sides of the inequality there that you would ask that it asked for.
You wouldn't just do the one only.
No, ma'am. If it was equal to like the warm up, yes, you would.
Wait, it is you.
It's so easy right now. You're like, that was sugar. It's easy. No, it is not. City Coast there?
What's Brandon's?
What are you talking about? We call him Mr.
155.
Yeah, how much time is really incredible? Dad? He has the same hair as Dad. Right, but he doesn't have the chin like Dad. He still looks like Coach, I was looking at the restroom. I was looking at his size. It's so bad. This is little if you wore a hat, I thought I was the only one. He's chill. Like he comes up and talks to me. I like to look at his stats. No, but physics is easy. Dude, you're doing geometry.